Okay, so we're going to be multiplying and dividing rational expressions today, and we're going to do this using our product rule. And you've used the product rule already earlier this semester, because remember, when you wanted to do something like this, square root of 8, and you wanted to simplify it, you split it up into the square root of 4 times the square root of 2. Remember doing that? And you would simplify this to 2, which would give you 2 square roots of 2. And we were all pretty good at doing that this semester. This right here demonstrates the product rule. All right? So the product rule is if you have any two roots, but the only catch is they both have to have the same index, then you can multiply them together under the same radical sign. All right? If they don't have the same index, you can't do it. All right? We can simplify them, but we don't know how yet. We're going to learn about that in a few sections. So, what I'm going to do first is go down here to some examples and show you. So, first of all, I've got the cube root of 6 times the square root of 2. You cannot multiply these because this is a cube root and this is a square root. All right? So, you cannot multiply. Over here, notice, both of our roots are cube roots, right? So we can simplify this using our product rule. Now, negative 4 times 2 is negative 8, so this would be the cube root of negative 8, and the cube root of negative 8 is what?
Negative 2.
Negative 2. So notice, we were able to use our product rule to simplify. All right, I will point out again, we already knew how to do square roots before, and we knew how to simplify square root of 8 by splitting it up into 4 and 2. We knew how to do that because we've worked with square roots before. We're going to do the same thing with cube roots now. So here's what we're going to do. At the bottom of this page, I've got some examples. So it says, what is the simplest form of the cube root of 54x to the 5th? Now, when I'm doing this, what I need to consider is these guys. You remember these? My cube roots that I know? Okay. So we want to know which one of these divides into 54. So if you don't know by looking at it, get your calculator out and do that. And I will tell you that 27 does go into 54 twice. So that's the first thing we're going to do is split it up into 27 and 2. So let's go ahead and do that. So I've got cube root of 27, and then I've got cube root of 2. Now, I have x to the 5th here. This isn't going to come out real nice. Some of them will come out and some won't. Would you agree? If I have x to the 3rd, that'll come out nice. Okay, so I'm going to do cube root of x to the 3rd, and I'm going to put the other ones, the other 2, separately. So I've got cube root of x squared. So I have split everything up using my product rule. This cube root of 27 is 3. Cube root of x to the 3rd is just x. All right? The others don't simplify, so I'm going to product rule them back together, and here's what you get. I've got 3x on the outside, cube root of 2x squared. All right? Next one. Top of your head, what goes into 128 out of our cube roots? 64 and 2. So we are going to split that out. So I'm going to do cube root 64, cube root of 2. Now, I've got x to the 7th. How many of them could I get out of there? 6 of them. So I'm going to separate, and I'm going to do the cube root of, not 6, x to the 6th, and the cube root of the very last x. Now, I'm not going to need absolute value at all because this is an odd index root. So no absolute values anywhere in this situation. Would you agree? Cube root of 64 is 4. Cube root of x to the 6th is? X squared. Yep. All right, so that's going to go out in front. 4 x squared cube root of 2x. And you have simplified it. So now, so you see how you're doing the same thing you were doing with the square roots? It's just a little bit more complicated because it's cube roots than square roots. All right, let's go to the next page. Now we're going to simplify a product. And so I've got square roots here, which is nice because that's easier for y'all. There are 2 ways that you can do this. You can try and simplify each of these first and then multiply them, or multiply them first and then simplify the whole big thing in the end. And it doesn't matter. It's up to you how you do this. So I'm going to do this one as multiply it all together and simplify it in the end. So if I multiply all this together, would you agree I'm going to have the square root of 720, and I would have x to the 4th, because here's 3 and 1 more, and y to the 5th, because here's 2 and 3 more. Okay, so far so good? Oh, goodness gracious. How can I split up 720? What can I take out of that? Remember, we have to use here our square roots. Square roots.
Square root 225.
225 does not divide into 720.
Oh, wait. Oh, yeah.
144 does? Okay. Oh, nice. 144, great work, and 5. All right? So here's how we'll split it up. Square root of 144 and the square root of 5. Now, x to the 4th is going to simplify, so we can put that by itself. How many of these can I put in by themselves to simplify?
3.
This is
4 and 1.
4 and 1 because it's a square root. So I can put square root of y to the 4th, and then here's that last y. Okay, let's simplify what we can. This is 12. This is what?
X to the 2nd.
X to the 2nd. This is what? Y to the 2nd. And that's all we can simplify. Now, you've got to keep in mind we have to look for the fact that do we need absolute value? We would need absolute value because this is an even indexed root, but we don't because once you square them, they're both going to come out positive, so we don't need it. So this is 12 x squared, y squared, square root of 5y. Okay? Now, I'm going to do the next one for you, but here's what I'm going to do. I'm going to show you an example where you simplify them first and then put them together, because you can. Just so you can see, and the thing it does prevent is getting a ginormous number like this. So here, I can use 9 and 5, right? Okay. So square root of 9, square root of 5, square root of x to the 4th, there is an x left over, square root of y squared, and there is a y left over. So that's that one. And let's go ahead and simplify what we can. So that's a 3. This is an x squared. This is an absolute value of y. And so what we've got here is 3x squared absolute value of y square roots of 5xy. Did I get everything?
Yeah.
Okay, let's do the next one. 35 isn't going to split up, is it?
Really quick, why is it the absolute value of y?
Because you have an even numbered root, you need to have absolute value unless it's squared, which will make it positive. You need to make sure it's positive. Yep. Yep. So this one, we've got square root of 35 because we can't do anything with that. And then we've got square root of x because we can't do anything with that. And square root of y to the 4th. All right. This, would you agree, is y squared? Okay. So this is times y squared square root of 35x. Okay, now we're going to multiply. Multiply everything together that's outside, multiply everything together that's inside. So on the outside, I've got 3x squared absolute value of y to the 3rd power, and then I've got the square root of, we need 5 times 35, 175, and then we've got x squared y, right? Now here's the downside. I still have to simplify again because the process of multiplying has created some things that will simplify. So just out of this, I can split this into square root of 25, square root of 7, square root of x squared, and square root of y. This is going to be 5. This is going to be absolute value of x. Now, what I'm going to need to do is combine these guys that I just pulled out with all of this. So I've got 15 absolute value of x to the 3rd, y to the 3rd, times the square root of 7y. All right? So that's just a different way of going about it. You can do it either way, whichever you prefer. All right, let me show you the quotient rule. You can see it here. Here was our product rule. Our quotient rule works really very similarly. I have square root of 2 divided by square root of 3. You can put it under the same radical sign and make it the square root of 2/3, or you can do it in reverse. The only thing you need to keep in mind is, once again, similar to the product rule, your quotient rule, you need to have the same index in your separate roots. All right? Now, I find that this is really handy for simplifying some things that could otherwise be quite ugly. So let's take a look at these examples. So I have 2 square roots. So this is the square root of 18 x to the 5th over 2x squared. Agree? Simplify the fraction. Whoops, this should be to the 3rd. Sorry. Okay. Simplify the fraction. So here's what we're going to do. 18 divided by 2 gives us 9 on top, right? And actually, 5 minus 3 gives us x squared, right? And what's the square root of that? 3 absolute value of x. 3 absolute value of x. Now, no absolute value business going on over here because this is an odd indexed root. But we're going to do the same thing. We've got a cube root and a cube root. So let's go ahead, use our quotient rule, and we'll make this one fraction. So I think we're going to need to know what 162 divided by 3 is. How about 54? Seem reasonable? Okay. So this is the cube root of 54, and then 5 minus 2 gives us y to the third. Fair enough? Okay, go back to your cubes. How can we split that up?
9 or something.
Well, you can't use 9. We have cube roots, so this is what you can use.
27.
27 and 2. All right, so remember, when you're working with cube roots, you can only use the numbers that have perfect cubes. So 27 and 2. So here's what we've got. Cube root 27, cube root of 2, and I got to scooch the camera over here. Cube root of y to the third. And would you agree this is going to give you 3 and this is going to give you y, right? Okay, so here's what we've got. 3y cube roots of 2. Beautiful. Okay. Last page that we're going to cover today. This is probably the toughest thing we'll talk about today, and that is rationalizing our denominator. We did talk about this with square roots before, and recall that when we had something like 1 divided by the square root of 2, we would multiply it by the square root of 2 over the square root of 2, because rationalizing the denominator means no square roots in the denominator, right? On top, 1 times the square root of 2 is the square root of 2, and on the bottom, square root of 2 times square root of 2 is the square root of 4, which is 2. Okay, so that's rationalizing the denominator. Here's what we're going to do. We have to do the same thing with cube roots here. Okay, so first thing I'm going to do here is I'm going to use my quotient rule and split this up so the top and the bottom are separate from each other. Okay, the tricky thing is we need to get this bottom part here to be a number such as these. Alright? And I think that the way that we're going to have to go with this is maybe we've only got up to the cube root of 125, which is 5. 6 to the third power is 216. So I don't necessarily want to write it on there, but I will write it over here. So the cube root of 216 is 6. And the reason why I had to go up 1 is I need to get to something that I can multiply by 12 to get to this number, and it will simplify. So I did go up 1. All right? Now, what else do I need? I need to get to 216. So 216 divided by 12 is 18. So I need to multiply by cube root of 18. How many more y's do I need to get to y to the third? 1 more. How many more z's do I need to get to z to the third? 2. Okay? Put that same thing on top. Okay. The bottom, when you put this together, is going to simplify completely. That's the whole goal. The numerator could be a mess. You never know. So the numerator is the cube root of 18 times 5 gives us 90. And then I've got x squared, y, z squared. On the bottom, this gives me the cube root of 12 times 18 is 216. I've got y to the third. I've got z to the third. All three of those things in the denominator are going to simplify nicely. So on top, cube root of 90 x squared y z squared. On the bottom, 6 y z. It's a lot trickier than the square roots, because when you're doing the square roots, you just use what's in the denominator. With the cube roots, you've got to get to a perfect cube. So let's do one more example. So you see this guy right here. Let's pull our cubes out again. How about this? I could get to 125, right? That would be good. So I'm going to I need to multiply by 25, right? 25, okay. So times, do the denominator. So I need 25. How many more y's do I need? One more. Make the numerator the same exact thing. Okay, use your product rule in the numerator. And I need 25 times 7, I think that's 175 xy. On the bottom, this is the cube root of 125 y to the third. This whole bottom will simplify now, and you won't have any more roots in the denominator. I don't see how there's anything we can do with the numerator. And the bottom will be 5y.